The theory of plate tectonics. Earth's lithosphere is not a solid piece of rock. It more looks like a broken eggshell with pieces separated by jagged cracks. In 1965, a Canadian scientist by the name of Wilson observed that there are cracks in the continent similar to those on the ocean floor. He stated that the lithosphere is broken into separate sections called plates. The plates fit together along these cracks in the lithosphere. Wilson combined what he knew about seafloor spreading, Earth's place, and continental drift into a single theory, the theory of plate tectonics. The theory of plate tectonics states that pieces of Earth's lithosphere are in slow, constant motion, driven by convection currents in the mantle. The theory of plate tectonics explains the formation, movement, and subduction of Earth's plates. Geologists believe that the movement of convection currents in the mantle is the major force that causes plate motion. As the plates move, they collide, they pull apart, or they grind past each other, producing changes in Earth's surface that include volcanoes, mountain ranges, and deep ocean trenches. Scientists have been able to measure that the plates move from 1 to 24 centimeters per year. The North American and Eurasian plates are moving apart at a rate of 2.5 centimeters per year, which is about as fast as your fingernails grow. Right now, that doesn't seem like much, but these plates have been moving apart for tens of millions of years. All Earth's plates meet at what are called plate boundaries. The break in Earth crust where rock slips past each other are called faults. There are three types of plate boundaries: divergent boundaries, convergent boundaries, and transform boundaries. San Andreas Fault is one of the most famous faults in the United States and is an example of a transform plate boundary. A transform boundary forms when two plates slide past each other. As they move past each other, the plates can get stuck and stop moving. Stress builds up where these plates are stuck, and eventually that stress gets too great and the rocks break, suddenly moving apart. This results in a rapid release of energy known as an earthquake. Mid-ocean ridges are located along divergent plate boundaries. A divergent boundary forms where two plates separate. When the seafloor spreads at a mid-ocean ridge, lava erupts, cools, and forms new oceanic crust. Divergent boundaries can also exist in the middle of a continent. They pull continents apart and form what are called rift valleys. The East African Rift is an example of a continental rift. The final type of plate boundary is a convergent boundary, which forms when two plates collide. The denser plate sinks below the more buoyant plate in a process called subduction. The area where a denser plate descends into Earth along a convergent plate boundary is called a subduction zone. When an oceanic plate and a continental plate collide, the denser oceanic plate subducts under the edge of the continent, creating a deep trench. This also is how volcanoes form, sometimes above these subducting plates on the edge of a continent. This process can also occur when two oceanic plates collide. The older and denser oceanic plate will subduct beneath the younger oceanic plate, creating a deep ocean trench and also forming what are known as island arcs. Now, when two continental plates collide, neither plate is subducted, and mountains such as Himalayas in southern Asia or the Rocky Mountains in North America form when the rock gets uplifted. It has taken the continents about 225 million years since the breakup of Pangaea to move to their present locations. What do you imagine the continents will look like in another 225 million years? It's time to show what you know.